Okay, so let's take a look at some different setups. So here we have different resistors. Before we just had one, so let's put them like this. So where you have to go through one and then go through the other one. Let's roll this out a little bit. Because they go in a pattern, or go through one and then the other one, they are called in series. You have to go through this one to go through that one. So what do we have here? We have a battery. Here's the high potential side. The current flows from high potential to low potential. So I have some current. Oh, you can almost see that. Let me change colors on that. So I have some current, and it's flowing that way. So it flows through the resistor that way, flows through the resistor that way, and then back around. So we'll call this one resistor 1 and resistor 2. The current is flowing from here to there. That makes this the high potential side and the low potential side, because current's flowing from high potential to low potential. So that means there is a potential across resistor number 1. There also, let me zoom in a little bit more here. There also is a potential across resistor number 2, because the current is flowing this way. This is the high potential side. This is the low potential side. This is the current across number 2, or the potential across number 2. The current that's flowing through this one has no other place to go, so it has to go through this one. So the current through resistor 1 is equal to the current through resistor 2, which is equal to that one. So now let's go back to Ohm's law. P equals IR. I have a battery. This is V battery. I have as I'm moving across, as I move from this side of the battery to that side of the battery, I'm doing it in 2 steps. The first step is here, the second step is here. All of the energy has to go away. By conservation of energy, all of the energy has to be used up when I come back around. So then when I give it more energy, it falls back out again. So the V of the battery has to equal the V across 1 plus the V across 2. But V1 by V equals IR, this is the current through 1 times the resistance of 1. The current to resistance of 2 is my V battery. So now, current 1 equals current 2 is just the current that comes out of the battery, IR1 plus IR2. And now I equals R1 plus R2. And that equals the V of the battery. What does this mean? This is the equivalent resistance. So if I have this series circuit, the velocity of my circuit is going to equal the I of the circuit times the resistance of the circuit. And when they're in series, resistance in series is R1 plus R2 plus R3. So if I have 2 resistors in series, so if I have 12 volts, it goes up, and I have a 3 ohm resistor and a 4 ohm resistor. Do I like that number? Sure, why not? 4 ohm resistor, and it comes through. Your question is, number 1, what's the equivalent resistance for this series? This is EQ. Number 2, what's the current? Those are your questions.